Hi, Assalamualaikum. In this video, we will continue with Series 4, a virtual workshop for final exam preparation, Calculus 2 for Engineers, MAT235. Hope you enjoy this video. Now we go to another segment, which is sample of final exam paper, right? Right, from this sample of final exam papers, we have 3 printed pages, okay? And then we have 5 major questions. Question 1, 2, 3, 4, and 5, okay? And the total marks equals to 100 marks. And the percentage equals to 60%, okay? And then all these questions you need to answer within 3 hours time, okay? And another 30 minutes you use to scan and upload your answer, right? Next, we look at the sample of solution. Now we continue with question 4a. Question 4a. Determine the solution of the homogeneous equation dy over dx equals to 2y squared plus x squared over 3xy, 7 marks. Okay. To solve this question, step 1, we need to write dy over dx as a subject. In this question, it is already given dy over dx as a subject. So we just rewrite dy over dx equals to 2y squared plus x squared over 3xy. Okay. Next, step 2. We need to substitute y equals to uv into variable y here. And we substitute dy over dx from left hand side here equals to x du over dx plus u. Okay. After we substitute, so we get this. Okay. Dy over dx, we replace by x du over dx plus u. And then equals to 2. And then we replace y equals to ux in bracket squared plus x squared over 3x. And we replace y equals to ux. Right? After that, we simplify ux in bracket squared here. So we get right hand side equals to 2 u squared x squared plus x squared over 3 and then x squared times u. Right? From here, we have each term containing x squared. So we can factorize x squared in numerator here. Okay, so we have x du over dx plus u equals to x squared. In bracket, we have 2u squared plus 1. So that when we expand, we get back the numerator from right hand side. Okay, and we still have the same denominator 3x squared u. Right? From homogeneous equation under first order ODE, the idea when we solve the equation, if we have homogeneous equation with degree 2, we can factorize x squared so that we can simplify x squared from numerator and x squared from denominator, right? After that, we have x du over dx plus u equals to 2u squared plus 1 over 3u. Okay, from right hand side here, no more x squared after we simplify x squared in numerator and denominator. Alright, and then at this point, now we want to separate variable u and x. Okay, so first we need to move plus u to right hand side. So we get this. Okay, we have left hand side equals to x du over dx and then equals to 2u squared plus 1 over 3u and then minus u. Okay, from here we have fraction with different denominator. Okay, because this is u over 1. Okay, so what should we do? We need to standardize the denominator. Okay, so we have x du over dx equals to 2u squared plus 1 minus u. We need to multiply u here by 3u because we want to combine all the denominator now equals to 3u, right? Next, we need to simplify, okay, the numerator. Okay, so we have x du over dx equals to 2u squared plus 1 minus 3u squared over 3u. And after we simplify numerator, so we have x du over dx equals to 2u squared minus u squared equals to minus u squared, and then we have positive 1 in front here, and then over 3u, right? From the previous slide, we get this, okay? Next, we continue with step 3, separating variables u and x, okay? So after we separate variables u and x, so we get this, okay? Let's say we write all terms containing u and du to left hand side, and we write all terms containing x and dx to right hand side. So we get 3u over 1 minus u squared times du equals to 1 over x times dx. Okay, at this point we success separating variables u and x. Okay, next we continue with step 4, integrating both sides. Okay, we just put integration sign for both sides. Okay, from left hand side here, we integrate with respect to u. And from right hand side here, we integrate with respect to x. Okay, how to integrate 3u over 1 minus u squared du? Okay, from here, we can use u substitution. But we already have variable u here. So let's say we use variable t. Okay, so we let t equals to denominator 1 minus u squared. Okay, remember when we use u substitution, or in this case t substitution, we will have derivative part and integration part. Okay, under derivative part, we need to differentiate. Okay, so when we differentiate t with respect to u, so we will have dt over du. And then we differentiate 1 minus u squared, we have negative 2u. After that, we need to write du as a subject. So from here, we just cross multiply. So we have du equals to dt over negative 2u. Okay, then we substitute here. So we have integration of 3u over 1 minus u squared du equals to integration of 3u over, we replace 1 minus u squared equals to t times, we replace du equals to dt over negative 2u. If we choose the correct substitution, we can simplify variable u here. Okay, after we simplify variable u in numerator and in denominator here, and at the same time, after we move out constant 3 over negative 2 or negative 3 over 2, so we will have integration of 1 over t dt. Okay, from here we can integrate with respect to t. So after we integrate, we still have constant negative 3 over 2, and we integrate 1 over t dt, we have ln modulus t plus c. Okay, next we replace t equals to 1 minus u squared. Alright? So after we integrate 3u over 1 minus u squared du, it is equals to negative 3u ln modulus 1 minus u squared equals to, after we integrate right hand side, okay, after we integrate 1 over x dx, we have ln x plus c. Okay, we just put plus c on one side only. Alright? Alright, and then the final step, Step 5. From y equals to ux. Okay, remember under step 2, we write y equals to ux. Okay, so we can replace u equals to y over x. Okay, if we write u as a subject, so we can write u equals to y and then over x. Okay, so from here, after we replace u equals to y over x, so we get this. Okay, negative 3 over 2 ln modulus 1 minus, we replace u equals to y over x and then bracket squared equals to ln x plus c. Right? So this is the solution for this homogeneous equation. Right? Next, we continue with question 4b, right? Question 4b. Find the general solution of the linear equation x squared dy over dx plus 2xy equals to z squared x. 7 marks. Okay. To solve this linear equation, step 1, we need to write into the form of dy over dx plus pxy equals to qx. Alright, from this term, okay, we need to write coefficient of dy over dx equals to positive 1. Okay, and then the second term should be term containing y. Okay, and right hand side should be term not containing y. Okay. Alright, to write the coefficient of dy over dx equals to positive 1, so we need to dividing each side or each term by coefficient of dy over dx, which is x squared. Okay, like this. Okay, so after we dividing each term by x squared, and after we simplify, so we get dy over dx equals to, from here we can simplify x in denominator and x in numerator here. Okay, so we get 2y over x, or we can write 2 over x in bracket and then times y. Okay, equals to z squared x over x squared. Right? At this point, we done write into the form of dy over dx plus pxy equals to qx. Okay, then we continue with step 2. Identify px and qx. Okay, from here, after we compare one by one, okay, we compare dy over dx equals to dy over dx and then plus, and then we have plus here. So we have px equals to 2 over x. Okay, and then we have y here equal, and we can write qx equals to z squared x over x squared. Right? After that, step 3, we need to find if. Okay, if means integrating factor. Okay, the formula for if equals to e to the power of integration of px dx. Okay, so from here, we replace px equals to 2 over x. Okay, and then to integrate 2 over x dx, we move out constant 2 from integration sign. So now we have integration of 1 over x dx. Okay, so we can write e to the power of 2 integration of 1 over x dx. Okay, when we integrate 1 over x dx, we have ln x. Okay, now we have if equals to e to the power of 2 ln x. Okay, after that, under properties of logarithm, we can move constant 2 in power here. Okay, so we can write e to the power of ln x squared. Okay, if we have e to the power of positive ln, we can simplify. So we have x squared only. Alright, so x squared is our integrating factor. Alright, after that we continue with step 4. Okay, the solution is given by this formula. Y times IF equals to integration of QX times IF dx. So from here, we replace one by one. Okay, so we have Y times our IF equals to x squared and then equals to integration of, we replace QX equals to sec square x over x squared times, we replace IF equals to x squared and then dx. Okay, from here we can simplify x squared here and x squared in denominator here. So after we simplify, we have y x squared equals to integration of sec squared dx. Okay, right, from here we can straight away integrate. Okay, so after we integrate right hand side, so we have tangent x. Okay, after we integrate sec squared x dx, it is equals to tangent x and then plus c. Okay, on the left hand side we still have y x squared. Okay, we no need to integrate because there is no integration sign here. Okay, right, after that we can write y as a subject, so we move x squared to right hand side. So we have y equals to tangent x over x squared plus c over x squared. Alright, this is the final answer. Okay, when we write y as a subject. Right? Got it? Next, question for C. Question for C. Find the particular solution of the separable equation x dy over dx equals to xy plus x plus y plus 1 given the initial condition y1 equals to 0, 8 marks. Okay. Right, to solve this separable equation, step 1, we need to separating variables y and x. Okay. Alright, from the given question here, okay, we can factorize x from xy and plus x here. So after we factorize x, so we have x and then in bracket y plus 1. So that when we expand, we get back xy plus x. Okay. Right, from right hand side here, okay, look at this. Okay, we have y plus 1 here and y plus 1 here, means same term. Okay, so let's say we write y plus 1 equals to t. Okay, after we write y plus 1 equals to t, we get this. Okay, x dy over dx equals to x and then t plus t. Okay. Alright, from here, we can factorize t. So in bracket, we have x plus 1. So that when we expand, we get back this. Okay. After that, we replace back our t equals to y plus 1 and then times x plus 1. Okay. Right. At this point, we get multiplication function. Okay. So we can move to left hand side. Okay. After we move bracket y plus 1 to left hand side, so we get 1 over y plus 1 times dy equals to, we still have x plus 1 on the right hand side, and then after we move x from left hand side, I mean multiply by x, okay, from left hand side, when we move to right hand side, we get divided by x and then times dx. Okay. At this point, we success separating variables y and x. Alright. Next, we continue with step 2, integrating both sides. Okay, we just put integration sign for both sides. Okay, for both sides, we integrate with respect to y. And for right hand side, we integrate with respect to x. Right? Right, from right hand side here, okay, we can separate this fraction. So we have x over x plus 1 over x. Okay, and then from x over x, we can simplify equals to 1. Okay, to integrate 1 over y plus 1 dy, we have ln and then modulus y plus 1 equals to, since we have plus sign here, so we just integrate 1 by 1. Okay, after we integrate 1 with respect to x, so we have x. Okay, and then plus, after we integrate 1 over x dx, so we have ln x. Okay, then after we done integrate, we put plus c at the back. Okay, because this is indefinite integral. Right? From the previous slide, we get this. Okay, this is called the general solution. Okay, since from the given question, we have initial condition y1 equals to 0, so we need to continue with step 3, applying the initial condition y1 equals to 0. Okay, how to apply this initial condition? Okay, we need to substitute x equals to 1. Okay, the value in bracket here means the value of x. Okay, we substitute x equals to 1, okay, into whatever x, and we substitute y equals to 0 into whatever y here. Okay, so we get this. Okay, then we have ln 1 equals to 1 plus ln 1 plus c. Okay, ln 1 is equals to 0. So we can write 0 equals to 1 plus 0 plus c. So our c equals to -1. Right? Right after that, we can substitute the value of c into this general solution. So hence, the particular solution is ln modulus y plus 1 equals to x plus ln x, and then we replace c equals to -1. Okay, so this is the particular solution, okay, for this separable equation. Right? Madam, boleh kita rehat sebentar? Baiklah anak-anak, kita take file dulu, kita sambung lepas ni ya. Coming up next, sample of final exam paper MAT235 Calculus 2 for Engineers, ODL. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.